Alright, 21. Differential equations. So we have this dy dt equals ky, and k is some non-zero constant. Then y could be one of these. Well, you might have this rule down already, but if you don't, let's actually solve this differential equation. So, we start off, we know that dy dt is equal to ky for some constant k. And the first thing I always need to do is separate the variables. So I'm going to try to get all of the y's over to the left-hand side, all of the t's over to the right-hand side. And I can only do that by multiplication or division for this. So I'll multiply both sides by dt. So I'll have dy is equal to ky dt. And I'll get the y over here. Now I could bring the k with it. It's not really necessary. I'll leave the k on this side. And I'll do that by dividing both sides by y. And that means that I'll have dy over y is equal to k dt. And now I have all of the y's on this side, all of the t's. There aren't any t's other than the dt on this side. And I can go back from this dy to just having y's by taking an indefinite integral of both sides. And the indefinite integral of 1 over y, or dy over y, is just going to be the natural log of the absolute value of y. That absolute value is actually pretty important in some cases. This is one of them. And the integral of some constant with respect to t will just be kt. And I'll have a plus c over here. You can't forget your plus c's, your arbitrary constants, when you're taking indefinite integrals. Two things. I want to get y by itself. I want to see what y would be. I have this natural log, that's the first problem, and then I have these absolute values. So let's get rid of the natural log first, and we should know that I can get rid of the natural log by using these left and right hand side as the powers of e. So if I have e to the natural log of y, natural log of the absolute value of y, that will equal e to the kt plus some arbitrary constant c. And e to the natural log, the power of e to the natural log, which is log base e, these will sort of cancel. We'll get the absolute value of y on this side. Over here, let's leave it at this for now. We'll have to do a few things over here, and we'll have to take care of these absolute values. So e to the kt plus c. Now, we don't like this plus c here. We actually like to write a little differently when we solve this, and let's take care of that right now by remembering that e to the kt plus c, we have the addition, the sum of two numbers in the exponent here is just going to be equal to e to the kt times e to the c. If you don't remember that, when you multiply two exponent expressions here, you add their exponents when the bases are the same here. And I'm actually going to flip these around and say, okay, so we have e to the c times e to the kt, and I still have this absolute value of y on this side. Okay. Few more things. I have this absolute value to take care of, and I know if the absolute value of y is equal to this expression over here, then y will either be the positive or negative expression over here. So I'll have a plus or minus. Plus or minus e to the c times e to the kt. But we can't actually have the plus and the minus. If y is going to be a function, it has to be one or the other. And the way we take care of that is by lumping this all together. The first thing to notice is e to some arbitrary constant. He's a constant, he's a number. And e to some arbitrary constant will be a number. And if I have to choose a plus or a minus, I can say, okay, this will be some positive or negative number, and we'll just call that a. You could choose any number you want. You call it y naught, the initial y value, but I'll just call it a for now. And so we know y equals a e to the kt. It has to be in this format where there's some number a. And we look at these choices now, and we have my choices e to the kyt. Well, that doesn't fit this case. I just have a kt in the exponent. 3e to the ky. That doesn't fit either. I just have a kt up here. Negative 4e to the kt. This a, it could be positive or negative, and it could be some constant, so c should be my answer. I'll circle it now, and we'll just go through and say, okay, 1/2 ky squared plus 4. Obviously not right. I need to have this e to the power to get rid of that natural log, so that one couldn't be it in kty. Same idea. I need to have an e there. So my answer for 21 is C.